right, everybody, please take your seats. Please take your seats. But terrible slapstick is how it works. Actually, Bree, would you like this wireless headset? Or are you happy with you're okay with that? All right, cool. Has anybody ever heard of Wired Magazine? Look who's on the cover of Wired Magazine this month. Not me. If you can't see, it's not me. It's Bree over there. I was like, that would be cool if it was me, but it's not me. It's Bree who's standing over there. Bree is about to be on the stage. He's our keynote speaker for today. This is the thing. You can make all the 3D models you want. But right now, the way they live is they live on a two-dimensional screen. And if you want somebody to interact with that model, the best you can do really is like hand them a mouse and say, click here to orbit and then do this. And if you scroll here, it zooms and then go like that. And most people, they have no idea what the heck is going on. It's kind of a miserable thing. You get 3D, which is an amazing way to interact with three-dimensional information, in 2D, which is a terrible way to interact with 3D information. So what's the solution? Clearly, it's the holodeck on Star Trek. Everybody can agree, right? The holodeck. And be like, you're like, boop, 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 boop. I want a cafe in 1846. Boop, 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 boop. I want a brothel. Welcome, Commander Riker. So these things show up, obviously, but what's between those two things, right? What's between your crappy little computer monitor and your mouse and your ba-ba-ba-ba-ba and the holodeck where you're like, oh, here's a dinosaur, or something like that, right? Clearly, it's 3D printing. It's the ability to take your model and make it into something physical, which you can physically hand to some other physical person, and they can physically hold it in front of them like this and go, yeah, you need to change this. I need you to change this again. So that part of the process isn't going to change. But the part where you actually get to show people what you mean is, and that's what's so exciting. Bree is a former teacher, right? You're a former teacher who had this idea, along with one or a few other people, for democratizing 3D printing. Instead of saying, we're going to make this huge hardware and we're going to park it outside your house, it's like the size of an RV, and also you're going to have to mortgage your house or sell a child or something to use it, what if this was like a microwave? What if it was something that you could just stick on your desk and it could make stuff? So with that, it's my great pleasure to introduce Mr. Bree Pettis of MakerBot. Big hand for him. Thanks, Bree. Thank you.
All right, let's see if my slides work. So this is me when I was learning how to make bikes. There's bikes. This is NYC Resistor, the hacker collective that I started with a bunch of friends. And this is my friend Raphael, who is operating a robotic drink-making machine. And just a pro tip, never put a random button on a drink-making machine. Especially a big red button, because people cannot resist a big red button. And like gin and whiskey and vodka and tequila should not go together. But you can see how fun it is to make people do it. So this is early days at MakerBot, and here are our wooden printers. So this is the one all the way on the left is a little prototype. And then we've got the Cupcake CNC, the Thingimatic, and the original replicator now, because we just launched the replicator too. And here's the new one. And just the industrial designer, engineer part of my soul just goes, ah. And for the tractor people, that's not a John Deere tractor. That's a, what's that? It's an Oliver. I think it's is there a McCormick type of tractor? Anyway, everybody's really called us out on this because we did it in John Deere colors, and there's like, you can tell the serious modelers in the audience because like, it's not a John Deere, even though you've got the colors. That's bad. So here's the Makerware looks like. So this is a build plate. It's a virtual build plate, and then you eventually make it, and it makes it real in the same size. And one of the things I'm excited to eventually work out is how to go from SketchUp to a little button in SketchUp that says make it, that then just makes your machine start going. Yes, says somebody from the front row. So this is actually sped up. So this is a building that basically fills up the whole build area, which is 11.2 by 6.1 by 6 inches. And with a 6% infill, it takes 23 hours. So the good thing about that is that the biggest thing you can possibly make takes about a day to make. And if you want to make it take less, you can actually make it have less infill. You can choose 6%, or you can choose totally solid plastic, or you can choose totally hollow, however you want to dial it in. That's how fast it really goes. And this is showing that you can make lots of things at the same time. This is a gratuitous owl photo. And what I want, the resolution of the projector doesn't really do it justice, because what I'm showing is that each layer is the same thickness as a piece of computer paper. Just colors. So, how many of you designed things for a living, just out of curiosity? Oh, yes. I love being in rooms like this, because you are the people who are changing the future by literally designing it. It used to be that when you wanted to make a product, there were like all these bothersome details between you and the product. And we're just in the most fantastic time ever, where electronics are modular. So let's say you want to make a contraption that wakes you up. You have to take the train every day, and it's like a 2-hour train ride or whatever, and you want to be able to fall asleep, and you want to be able to wake up about a minute before you get off the train. But the trains are not always running at the same time, and sometimes they're late. Like, you could just get a GPS module, hook it up to an Arduino, or everybody's really excited right now about the Raspberry Pi, which is a miniature computer for $35. And you could write some code, or you could even borrow some code probably and just hack it together and make it so that and you'd have to have like a little speaker or buzzer on there, so that when it gets to a certain geographic point and the GPS knows that it's near there, the buzzer goes off and you wake up. And then you could use a MakerBot to make a case for it so it's not falling apart and you don't get electrocuted. So this kind of idea of being able to pull things together, to pull projects together, it's just never been easier. It's never been more modular. It's never been more friendly to jump in and play with things and make products. So I mentioned hackerspaces earlier, places where people go to play, and also places where you can find experts. If you go to a hackerspace and you're working on a project and it's enticing, and you say, does anybody know about flux capacitors? Somebody in the room probably has put one together. And then you've got Kickstarter. I wish Kickstarter had been around when we started MakerBot. We raised some money at the beginning, and we could have just pre-sold on Kickstarter. So that's an interesting idea. It's an exciting time to be able to get ideas out into the world. I think I've said this like 5 times. We just opened a store. I'm really proud of it. We just saw like a physical store with things in it, and MakerBots and things to buy that were made on a MakerBot. I think this is also there's more people than us doing this right now, this idea of an internet company having a store. What would a SketchUp store look like in real life? I'm not sure. I'd love to walk into it, though. You could model it, and I could have the virtual experience, I suppose. We're just getting an office. I'm just saying this because I'm super excited. Because right now we're working in a place that looks like this. So it's going to be awesome to have an actual office, like with tables. We have a site called Thingiverse, which is kind of like the warehouse, except all the things on here are things. They're not just models. So, you saw the tractor there earlier, and you can actually download this and make it on your MakerBot. This is in Chicago, the Art Institute, and this guy named Tom Burton would really like that line, so he went and he scanned it using photogrammetry, which is getting pretty easy these days, and then just made a model of it. So he has, and people keep wanting them, so he just gives it to them and makes more. So he's made a bunch of them, and now and then he inspired the Art Institute of Chicago to start sharing their things. So the idea of having places, being able to take your work and share it, whether it's on Thingiverse, or the warehouse or wherever. I just think that's so cool that we can take models and share them, and everybody's better for it. Little story about this. We did a thing. It had been one of my personal goals to steal everything from the Metropolitan Museum of Art for a while. And then we met with them, and I kind of told them. And it turned out that we had the same goal, which was to share it with as many people as possible. So they actually invited us in, and we did this whole project with them. We brought in a bunch of artists and scanned lots of stuff, and then shared the models, and then remixed them, putting different people's heads on different people's bodies, and that was fun. So some stories. There's a guy named Calm Tom and his daughter. His daughter is 41.5 inches tall, and they're going to an amusement park. You talk about a superhero dad. I'm going to just make you taller now. Those are little inserts for her shoes that make her tall enough. That's a MakerBot smile. This is my favorite thing on Thingiverse. This is a Duplo to Brio adapter. And if you are a dad or a mom, yeah, right? Neither of these companies, Lego or Brio, would make this adapter because they have systems that have like nice fences around them. But when you have pieces like this, it changes the whole playset. And inspired by this, there's a group that made a construction set that took every out-of-patent playset, from Lincoln logs to those little bristle blocks to all those there's like 40 of them, and made things like this to make it so that you could combine things that haven't been combined before, like connects and all that stuff. This is Casey Holgren. She's one of my favorite MakerBot operators because, well, she's just awesome. She's a stage designer, and she literally designs stages for Broadway. And she used to have to make her designs and then cut them with many X-Acto blades and lots of blood later. And now she makes the designs and then just prints them while she sleeps in her closet because she lives in a studio. And most of the things in this room are 3D printed. The door and the chimney and the stairs and the chairs. And you can even see, I like how on the bottom there's like notes from the director that are all like, move this chair over here. So this is a guy named Thomas from Rest Devices. So one of the cool things about this is the way making things used to work is you come up with an idea or you design something, and then it would take a couple weeks to a month to get a physical rendering of it, a model. And then you'd hold it in your hand and you'd be like, it's too small, or it's too round, or whatever you want to say about it. And he's got an old Thingimatic there, but it's a trusty old machine. And he was able to, he makes shirts that people wear at night to help with their sleep apnea, which is a problem where you don't breathe while you're asleep. It's kind of important to do. And so he was able to iterate really quickly. Instead of taking weeks, he's able to make new ones within hours even, and rapidly iterate till he was happy. This we've had this engine of failure in SketchUp and the design world forever. You don't like the way it looks, so I'll just change it. Oh, you don't like the way that looks, well, you change it. Okay, you make a rendering. Okay, we're ready to send this one off to the client. The client looks at it. He doesn't like it. We're going to change it. That ability to rapidly iterate has been in the digital world for a long time. Sometimes it takes a little while for things to render, but even then, it's still like within a day or two or something like that maximum. Now to take that to the physical world means that you can have ideas and you can fail as many times as you need to be happy. And this just means that better designs are going to happen because you can iterate more. It's like an innovation engine of awesome. Yeah, that's what I just said. So this is us about 50 people ago. We're about 150 people now. It's kind of absurd. we're just trying to keep up. And we make them in the USA. I'm just going to talk about this for a little bit because it's important to me. Here we go. We're making them in the bot cave because literally there's really no cell service in this room because the walls are like 5 feet thick and it's really a cave. It was a brewery in the 1850s in Brooklyn. And here's another space. These are 35 people I hired a few weeks ago to make the replicator too. And it's kind of filling up a lot. We had this one of these things that happens with real things that's different from virtual things is you can't just spawn up new boxes on Amazon Web Services. We had one piece, what we call the bot step, and it's a little stepper driver thing that plugs into the main board, and these got delayed. So we literally have like 800 MakerBots right now. They just came in, so we've started shipping out, and we're literally like plugging these things in and testing them and shipping them out as fast as we can because we built up this whole amount, getting ready to ship. Here's engineering. This is just kind of showing you what it's like to be a MakerBot. So we explored the world of manufacturing overseas, and I think for some people at scale, it makes sense. Maybe it won't make sense for much longer if you're seeing what's going on with the iPhone. But for us, we wanted, like, having manufacturing 12 hours, like literally on the opposite side of the world, at 12-hour time zones away, wasn't going to work for us. And the thing that you get in China is you get unskilled labor really cheap. But it turns out it's kind of important when you like have two holes that they match up if you're going to put a screw between them. And that doesn't always happen if people don't take pride in their work. So there's something very important about pride that you can feel in the air at MakerBot, and it smells good. And we can catch things really quickly, and we're just creating jobs as fast as we possibly can. And I'll just leave it at that. This is kind of all the stuff I was saying about how it's an awesome time. So I already said that. So now I'm going to switch gears a little bit. Let's see, about 15 months ago, maybe about 2 years ago, a guy showed up on Thingiverse, and he made this Gothic cathedral, which was made out of like 20 different parts that were all modular, that you could use as a playset and rearrange to make different shapes of cathedrals. And he made this all on a really early MakerBot, and we were just like, oh my gosh, this guy's so cool. And then he made all his holiday presents, which were like 1 foot tall Lego men. And he sent us one, and we're like, oh man. And then he made real-life Koopa racers, which if you've ever played Mario Kart, you're just like, yes. And I'm like, we got to get this guy in here. So then his job is literally to make cool stuff with SketchUp all day and then print it out on a MakerBot. And he's here. He'll actually be at the event tonight with an animatronic octopus that he made on his shoulder. So that's him when you see him tonight. Give him a high five. These are, for those of you who know what these are, I don't have to talk to you, but the buildings are all the buildings from SimCity. Yeah, you have to do it, right? This is the Iron Man thing that you embed in your heart. This shoots at you. This is like astronauts discovering MakerBot French fries. This is the Botmobile. This is a remote control 3D printable car, and literally all the parts are made on a MakerBot, and except for the electronics and the servo, and there's some bearings. I don't think we really need those, though. We could probably make them. More astronauts. Faceless zombie astronauts. So we did this thing was it last year? Goodness, it was almost a year ago at CES where we were like, let's just make big stuff playsets. So he pulled together these playsets of a spaceship and a castle. 5 more minutes, okay. Here's a bunch of princesses working on a car. They're cool. This is his desk. This is what it always looks like at his desk. I think he was originally going to just sit at part of this table. Didn't work out that way. There he is. Yeah. Go Pixar. This is the thing we did last May for Maker Faire. This is a robotic petting zoo. We weren't sure how it would go over, but it turns out that like 2-year-olds will hit a robot for as long as it's there, if there's a button on it. So Michael made these things, and then when we got the wired cover, he promptly remade them, and he set them up with a little microcontroller inside so that when you flip the switch, it waits 30 seconds and then starts just walking, and sort of it's a little bit random, and they fall over, and it's really cute. And it was so great. Like, the folks from Wired came over to do a photo shoot, and they're like, "You made these for us? How much did we pay you? They're so cool." And I'm like, should I just send them a bill for a lot of money? But we gave them to Chris Anderson. They're on his desk. This has been Michael's latest project, where he takes Sears houses. I guess there are many hundreds of Sears houses you could buy. The architects in the room are all going, yes. And you could pick it out of a catalog and then order it, kind of like the gentleman who was up here earlier, where it was like, okay, here's your house, order it. This was done a little while ago with paper in a different process. But so the top comes off, and the middle comes off. There's some details. And, this is like a hurricane just happened, a tornado just happened. Kansas, take me back. And these are just pretty. And so this is my last little MakerBot story. So this is a guy, Nick, and this is a Zeus wake frog, and he makes lures for people who fish. And you can see there's a little, in the middle of it is a deadly hook. And this was actually made, you can see the seam down the center, actually. And he makes them half and half and then glues them together and then covers them in putty and sands them down and then lacquers them so they get this just beautiful sheen. And I guess they catch fish. And for him, he's able to make these things custom, and he would never have been able to do this in any other way. And so for him, this is his ability. Instead of just selling other people's lures, he can create his own and make them himself and go into, small-scale production. So that's about where I'm at. Thank you. It's a pleasure to be here. It's very nice to be in Boulder. I have to say, I can see why you all live here. And I'm just really, SketchUp is very close to my heart. So I just want to, it makes me really, really happy to be here and talking. And I just can't get over how much that announcement just made me do a happy dance. So I can't wait to see what you do. I hope you share in some way what you do. If you can't share what you do at work, I hope you come up with just stupid and wonderful ideas and share those instead if you can't share the things you do at work. Or if you can share the things you do at work, I'd love to see more of them, to see what you do with SketchUp. And ideally, we can get a bunch of MakerBots in your hands. I mean, you should be able, if you work someplace, maybe you can actually expense it. Oh, good. I should probably mention that. Thank you. They're $2,200 for the new Replicator 2. And the material's cheap. It's about between $48 and $55 per kilogram, which is 2.2 pounds. It's a spool. We'll actually have them here tomorrow doing their thing, and so you can check them out and kick the tires. But I just have a palpable desire to see the things that you all make made real. So share them. If you don't have a MakerBot, you can share them, and maybe other people will make them and take pictures and all that kind of thing. So I'll leave you with that note. Thank you very much.
Thanks very much. That was terrific. We have time. That was fantastic, wasn't it? Hands up if you want to 3D print something like right now. Right now, I want to now. Okay, so the good news is tomorrow there's something called the Maker Lab Lounge at the venue where we're going to be. There's going to be MakerBots and people from MakerBot. You can bring your file, you can print, you can 3D print right there. And then after the design charrette on Wednesday, that design activity in the morning, the winning teams will face off in SketchUp trivia quiz, and the winners will win MakerBots. And that is kindly provided by the folks at MakerBot, Mr. Bree and his friends. All right, let's take a few questions. Who has a question? I have time for 3. Who do we have? Yes, back there. David. Can you mix colors?
So if you want to mix colors, so our last printer, the original replicator, came in a dual extruder option. And it meant that you could make things in 2 colors. And so you can do 2 colors now. We've been talking about like what would it look like to add more colors to have more crazy things. But the fact of the matter is most people like, what's interesting is you're like, we made 2 extruders and we're like, this is so cool. Everybody's going to do this. And then most people just use 1 extruder. So I think there's still room for the experimenters in the world to explore new ways to do 2 colors in one thing. But people who don't have that capability, if you have a MakerBot with just 1 extruder, with 1 color at a time, they just make multiple pieces and then just snap them in together. So one of the cool things about it is, even though you're limited by build volume and you're limited by whether you have 1 or 2 extruders on your MakerBot, you can always like work around it. Like you can make bigger things by making things that attach or snap together or go giant. There's no limitations.
Next question. Yes, miss in the front. Yes. Are you going to make a bigger MakerBot? They just released the Replicator 2 when?
A few weeks ago.
So you need to give them a little bit of a break. It's like this big now, but how big will the biggest MakerBot you make be? Answer now.
You know, one of the things that I want to do, and I mentioned this, and if I keep saying it, I'm going to make it true, is I actually want to make a MakerBot that will go to the moon, unfold, become really big, use a binder and moon dust to create the moon base. So, like, that's how big I want to go.
Okay, we need another question. Who has a question? Yes, sir, right here. How far off are you from using other materials besides the plastic or the plastic-like material that they use now?
Right, so we've got 2 materials now. The original replicator uses ABS, which is what Lego is made out of, and the replicator 2 uses a material called PLA. You can actually retrofit the original replicator, use PLA if you want. But PLA is this really cool material that I didn't talk about that I probably should have, that's made from corn and smells good, and it is really just amazingly, like, it's structurally sound, it's ultra strong, and it's dimensionally stable, which is important. ABS expands when it heats and then shrinks when it cools, which can be fussy. But it's tricky. Material science is hard. We've done like, we've a couple times we've been like, oh, we're going to release it. We've got a new material. Oh, yeah, let's try it out. And we spend like 1,000 hours doing all the testing. And then we're like, nope, that's too bad. Didn't work out. So we've got these 2. Of course, we would love to have more materials. And we did a bunch of experiments when we started with chocolate, which was just disastrously wonderful. You can eat your mistakes. So, but the paste extruders there's people who are also doing who are taking MakerBots and making them add clay extruders to make pottery. It gets just tricky because I would just say material science is hard and we're working on it.
We actually have time for one more question. So who has another question? Formerly disappointed person. I'm just going to look around. I'm going to take the one on the balcony because you got one before. Yes, sir, with the hair.
I was wondering if it's feasible to make a plastic model and use that to make a mold to form metal?
Is it possible to use the MakerBot or a similar 3D printer to make a mold out of plastic and then use that mold to create positives that are made out of some other material? Is that your question?
Pretty much,
Okay.
Yeah. So there's a process called lost wax casting that's really popular with jewelry makers, where they basically make a wax model, and then they take it to a forge, and then they literally just pour molten metal, whether it's silver or platinum or whatever, into the mold, and the wax just gets, I don't know exactly what happens, but it disappears. It turns to smoke, and then your ring becomes the ring. You can do that with plastic too, and it's a little, and it works. We basically have done some experiments where we've gone to a local forge, which is interesting. It has bulletproof glass this thick, because they store lots of gold and platinum there. And you're like, can I have this model? And they're like, no. They're very serious, yes. And then they make it, and you come back a few days later, and we get stuff made in bronze and brass and aluminum, and it's pretty cheap, actually. So I would say there's no process right now where nobody's truly blazed a trail into being able to do that and define that and shared that properly. But maybe that's for you to do.
The good news there, so I was a jeweler before I was an architect, so the good news about this, though, is that it means that you can make the positive. If the thing you had suggested was the case, you'd have to make the mold, right, which is hard to get your head around. Possibly you need the solid tools, which is in Pro. Awesome. But otherwise, what you can do is you can make the positive, and then you burn that out through this magic process, and it becomes a piece of metal. So it's like what you make becomes the metal, which is great. Terrific.
Cool. Well, thanks so much for having me here.
Thank
really
you so
good.
much, Bree. That was fantastic.